So what this review video is going to be on is on domain and range, or domains of composition of functions, and also how to compose functions. So um, what I'm going to look at, I've got a couple of different functions, and we're going to look at how do we compose them and how do we determine their ranges, and then how do we do some basic things with the composition of functions that will help us to understand what are composed functions. Okay. So let's suppose that we've got two functions. I've got f of x equals the square root of x plus 3, and I have g of x equals x squared minus 4. Okay, and let's say I want to find f of g of x and state its domain. Well, just to help to illustrate what does it mean to think about composition of functions, let's imagine that what I have over here, I'm going to have, this is all real numbers, okay? And so I have, these are all my x's, okay? And then I'm going to utilize a function, right? And this is oftentimes what we do to more of the real numbers, okay? I'm going to take g of x, and it's going to give me all of these g of x's over in here, and this is my range of g of x is all of this stuff in here. Okay. And then I'm going to go from there and I'm going to take f as my mapping, right? But because I've taken only the stuff that I've gotten back from g of x, right? All these in here are going to be my f of g of x's. Okay. All right, here's call it range 2. So I'll start out with all my x's, okay? And then I'm going to go over to g of x, and then finally I'm going to have f of g of x, right? After I've done the composition of the functions. How we write this, though, is we write it f of g of x because we do g first. Okay, so that's important. We're going to do g first, and that's why we write it like this. Okay? So when I go in here, what you're going to first think about is well, if I have to do g first, okay, I've got to make sure that I can do g. So its domain, right, the values that I'm going to have for my x's are going to be the domain of g. So we got to start with the domain of g. So start with the domain of g. Okay. And that's, if you remember, g of x equals x squared minus 4. So the domain here is all real numbers. All the real numbers, okay? So that's cool. Good. So we can put anything into here, and we're going to get back a value that's domain is all real numbers. And then we're going to use f afterwards. And so what I'm going to need, though, is not f. I'm going to need f of g of x because those are the values that I'm going to get. So I've already restricted to g, okay? And then I'm going to restrict to f. So if you look, f is x plus 3. So what I'm going to do first is, so I have f of x equals the square root of x plus 3. So first I'm going to compose those functions. Find f of g of x. Okay. Now, this guy, okay, what that's going to do is I'm going to put everywhere I see an x in f, right? So everywhere I see an x in f, I'm going to instead input in g of x. So what that's going to be is it's going to be now square root of x squared minus 4, right? There's my substitution, right? It went right down directly into there, plus 3. And so this will then equal the square root of x squared minus 1. Cool. All right. So this is the composed function. This is literally what f of g of x is. So if I asked you to find f of g of x, that's what I'm looking for. Now the domain of f of g of x now will be the combination of g of x, this domain, and f of g of x's domain. We call that, actually, it's going to be their intersection. Okay, say the intersection. So let me demonstrate what I mean by that. Well, f of g of x is the square root of x squared minus 1. And if you remember, we've got two issues with domain. We don't want x must be greater than or equal to, f of x must be greater than or equal to 0 if g of x equals a square root of f of x. So if we have anything into a square root, then we've got to have it be greater than 0. That's the first one. Call that number 1. And then number 2 is no division by 0. So those are our two big ones here. If you notice, for f of g of x, right here, we have x squared minus 1. So we need x squared minus 1 to be greater than or equal to 0. All right? As a restriction on the domain. All right? So then that means x minus 1 times x plus 1 has to be greater than or equal to 0. And what that means then is that we're going to have to do just a little bit of work here. We're going to put in our zeros. There's a 1 there. Our negative 1, right? We'll set x plus 1 equal to 0 and x minus 1 equal to 0. So x equals negative 1, x equals 1. Okay, so we have a negative 1 and we'll have a 1. First, I'll test out a value at negative 1. So this is going to be negative 2 minus 1. That's negative. And then negative 2 plus 1, that's negative. Negative times a negative. So over here, it's going to be positive. Then I'll pick a number between, right? I try x equals negative 2. Then I'll try out a number between negative 1 and 1. 0 is always easy. So that'll be negative 1 times positive 1. So I tried 0, and so this ends up being negative because that's a negative times a positive. And then I'm going to try a number bigger than 1. So let's take 2. 2 minus 1 is 1. 2 plus 1 is 3. So that's 3 times 1 that's a positive number over here. Okay. So x squared minus 1 will be greater than or equal to 0 when, right, we're going to have over here in negative infinity to 0 to negative 1, excuse me. And we're going to union that with this one over here, 1 comma infinity. And since there's no restrictions for g, this here is my domain. Okay. The domain of f of g of x is negative infinity to negative 1, union 1 to infinity. Okay. Let's try g of f of x. So again, I'm going to write, okay, how about g of f of x? So we'll let g of x, again, is going to equal x squared minus 4, and f of x is going to equal the square root of x plus 3. So what I'm going to start with is I'm going to start out with, since f is what's done first, right? That's the one that's inside of the parentheses. I'm going to find the domain of f. Okay. The domain of f is x plus 3 greater than or equal to 0, right? Because that's the thing in the parentheses. So x is going to have to be greater than or equal to negative 3, right? Or if we write that in interval notation, it's going to be negative 3 to infinity. Then I'm going to find the composition g of f of x, right? We don't find the domain of g, right? We're going to find the domain of the composition. So I'm going to take this, and what that's going to do, right, is I'm going to input in, everywhere I see an x and g, I'm going to input in my f of x. So this is now going to be the square root of x plus 3 squared minus 4. Okay? Then I square it, so that's going to give me x plus 3 minus 4, which equals x minus 1. Right? Now there's no restrictions on this domain. So the actual domain then is going to be, it's the intersection of the two of these. So in this case, my domain of f is negative 3 to infinity, so the domain of g of f of x is going to equal negative 3 to infinity. And here's how you want to think about this. If I pick a number that's less than negative 3, say I choose negative 4, then when I do f of x, because that's the one that's going to get done first, I'm going to get negative 4 plus 3, square root of negative 4 plus 3, which is the square root of negative 1. That's not a real number. So since that's not a real number, that means that I can't actually, I won't be getting a value there, okay? And so it doesn't matter what g is, because when I did f first, okay, I got no value for it, right? I got no real number, and so consequently, I have to take the restriction on the first function first, right, and then the restriction on the domain for the entire composition. All right, let me show you, demonstrate something about this. This was another kind of question that we had. Let's suppose, let's actually do this. Let's take g of f of negative 5, okay? Now this is going to end up equaling, right, if we rewrite this, it's going to be the square root of x plus 3 squared minus 4. Okay? Now, if we did the algebra, okay, actually, excuse me, the square root of negative 5 plus 3 squared minus 4. Well, the problem here is that we're going to get the square root of a negative 2 squared minus 4, which, if we were working with complex numbers, would be fine, but it's not okay if we're working with just the reals. So since this is a square root of negative 2, this is not a real number. So we can't find g of f of negative 5. It doesn't exist in the reals. Conversely, what if we took f of g of negative 5? And if you remember, with f of g of negative 5, okay, we didn't have, there were no restrictions on the, what we ended up having is that we needed x to be greater than negative 5, right? Okay, so if you remember, excuse me, the restriction here was negative infinity to negative 1 union 1 to infinity. So we're just fine here. Okay, well, let's try it out. So we'll take g of negative 5 is going to equal, well, first, we'll do g of negative 5. That's going to equal negative 5 squared minus 4, okay, which equals 25 minus 4, which equals 21. All good. Then we're going to take f, and we got f of 21. So it's just like you find g of negative 5, and you plug in that value into f, and so this is now the square root of 21 plus 3. That equals the square root of 24, which is certainly real. Okay, so we've developed some kind of basic principles for working with composition of functions. One, all right, first, well, suppose we wanted to find f of g of x. Okay, the first is find the restriction of g of x, the one that's inside. Then find the restriction of f of g of x. The restriction, this is the intersection of g of x's and f of g of x's domains. Then 3, input g of x into everywhere in f where we have an x. Then simplify. And that's it. That completes the video.